Hello YouTube viewers, welcome to my channel Science to Technology. In today's update video about my 3D printer design, I have made some progress. Basically, as you can see, now I have linear rails in these two axes. Also have started the foundation of Z axis. One thing I did realize that I cannot take the design any further unless I finalize the extruder itself. Now I'm not buying extruder, I'm trying to make extruder. Now the extruder that I'm aiming for, basically the end game of my extruder is basically making Hemera. Hemera is basically kind of amazing in terms of extruders. Let me load a picture of that. Boom. Now the reason why it's amazing is basically surprisingly compact. Like that's it, that's the motor, that's it. And here not only you have basically direct drive, which is present in almost everything, it has geared and dual drive, which means it will amplify the torque and grab the filament from both ends. So that's quite amazing. And because the body itself, this black part is acting as a heat sink, it does not require an independent heat sink. So you can see like this is a direct drive system where you have motor and then motor pushes the filament, but here's the you need an independent heat sink. So this whole area is missing in Hemera. So Hemera is surprisingly compact. Now I cannot buy it in India, and not to mention its price is ludicrously high. So even if I could buy it in India, I would not buy it simply because of the high cost. And I don't like the design simply because the way it's done, it's if you have only one thing to add into your 3D printer, like one extruder, is mind-bogglingly awesome, no denying that. However, I need to put two. So if you put two of them like this, problem is the cooling fan will end up choking itself. So that's not a good idea. On top of that, I do not like the design of cooling fan being facing this way. So I want to put it like, on the side. Benefit of that would be much larger surface area and bigger fans equals more airflow, less noise, which is desirable if I'm trying to make a best of the best 3D printer. So Hemera is good, but surprisingly a large number of people who have this actual stuff, they complain a lot about basically it jamming a lot. For some reason it jams a lot. Now this is basically Titan, which was the older version where they literally had a D shaft and basically lever directly, basically bad design. All it was a bad design, but it did had gear reduction, but it was plastic. So when they did Hemera, they had an independent axle, so it's not rubbing on the motor axle. So that's awesome. And you can see they built a like custom motor face plate, so that allows them, like this is a bearing seat and this is the step down. So everything is metal, so you can technically put this puppy in a heated build chamber, which my printer will be a heated build chamber. So I'm trying to avoid as many plastic parts as I can, at least in the main core components. And extruder is the main element. Basically, if extruder works, everything works. If it does, if it fails, nothing matters. So of course I'm not gonna have this. So building this whole section, I do have some friends in basically metropolitan, which they are suggesting that they can acquire certain things. Then yesterday I had a discussion with a friend about the bearings. Basically small bearings are a very big complicated thing that I have to buy. So as you can see, this is the whole point of it. The both side will be putting extreme force. So this why yesterday progress was not that high as expected, but I did manage to find that I can find bearings that are like relatively small, so to say. As you can see, that should allow me to use a normal rod rather than a needle bearing, which is like this. I don't think I can find this in commonly available parts. So minor progress have been made. So this will be the main component, so to say. If extruder works out, this printer will be worth it. Otherwise it's just a basic thing. And in terms of how many custom parts, that started to freak me out, because the amount of custom parts I need is starting to grow. I live in a small town, so don't have access to mill or even a drill press. Like I'm trying to access a friend who has a friend that has a drill press. So you can understand that it's like even making this plate, which I have to make custom. And as you can see, it's intersecting here to the bed. Now that's not an issue because it's intersecting only the basically insulation for the heated, but I would not like the idea of chopping off that, not only that motor and all that. Thankfully I can sink basically this whole assembly quite downwards, because there is a lot of room in the down, so I do not need this bulge. I can sink it down. If I go into the body, basically disable the center part, you can see like there is a lot of room there. And if I use countersinks nuts here, I can basically make it flush. This whole puppy I can bring it down a lot if I need to. So that's a one part that I have to. This is basically a plate of stainless steel, then some drilled holes, so nothing fancy. It should be doable, so to say, or at least I'm hoping for that. And then another part is this cross brace, that is basically bed plate. This I have to make it custom, because even if there is available one, they may not have, like, exactly designed for linear railings, MGN12 settings, so the whole patterns may not match. That's another issue. Now all those parts are surprisingly easy, and like I can do that with a handsaw if I need to, but doable. Those are doable. But designing basically metal parts that behaves like this puppy, that's the difficult part. So the designing process is kind of stuck at this moment, but I have made some early assumptions of costing, but it's costing around $700. At first I thought that's too high, but reality is for 300 millimeter printer square, like in India, $700, around 50,000 rupees. That's like I'm getting still underpaying, basically, so to say. So it's not too bad. And yeah, price will go up once I actually design the extruder and electronics and all that jazz. So right now I have only a rough estimate. So this project is making me appreciate all the people who made belt grinders, and like one of the dude who like really made a awesome belt grinder using welding parts and thick metals. He said it took him 1 year to design it, and I was like, why? Even if you are engineer, even if you are working part-time, you should be much more capable of that. Now I'm designing it, now I'm understanding it. It's not the designing part that can be done in a few minutes. It's just like design in such a way that you can actually manufacture it. That's a whole different ball game. So minor upgrade, but that's how it happens. Hopefully you had liked this little update about my current state of the project, and for Friday's video I will hopefully try to make a complete time lapse of all the modeling and all that, so you guys can see. So by this, I want to end this small update. Hopefully you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike twice to show me extra disappointment. And please press the bell icon if you're free. And as always, thanks for watching.